I'm a software engineer. I work on a product called Pivotal Cloud Foundry, which is a platform as a service. It's a container orchestration thing. We take your code and we put it in the cloud, we run it on a container, we make it highly available, we do logging, we do routing, we do a bunch of other things for you so you can focus on writing code and making your application work. I've been on a couple of different teams on Cloud Foundry. Cloud Foundry itself, by the way, is an open source project, but the pivotal part there is our closed source version of it. We have some tools layered on top of it. I've worked on a team that was testing the high availability features of Cloud Foundry, which was my first project where I was pairing the entire time. It was just me and Jesse Alford, who if you've met either of us, you know how loud that got very, very quickly. That's what that stoplight is it's a decibel tracker. It alarms whenever we start getting too excited about a bug. I've also been on the billing and accounts management team, Mega, which is our release integration team, and I am currently on the quote-unquote core service team. It used to be the core services team, but it turns out that making a highly available distributed MySQL release is complicated enough, and it's MySQL, but we use MariaDB, the open source version, is complicated enough that that's a full-time team. So I've been on a number of different teams. I've seen a number of different parts of the organization. But we don't have testers. We have engineers. We don't have a separate testing group. And the way that we do that is that everybody tests. Everybody tests. We talk to each other a lot. And we're constantly improving our process. And it turns out that that covers a lot of the things. We can get a lot of functions from that other organizations would get from having a separate testing group. We can find a lot of the problems, and we can, before they hit production or shortly enough after they hit production, that we can fix them quickly. And I'm going to go into a little bit more detail about what each of those things means. Because really calling this testing without testers is kind of disingenuous. It's a fancy title, but it's not really what we do. This is a tweet from an engineer that I worked with on the Mega team, Zach Auerbach. I was in the middle of drawing another diagram. I was doing a talk on exploratory testing for my team, and I was about to talk, more scripted on one side, more exploratory on the other side, and Zach, in the middle of it, was like, no, you have to stop, because I have to take a picture of this, and I have to tweet it, because this is how we think about testing at Pivotal. We're always testing. We're always looking for new ways, better ways to test. And that was not something that, I had brought to the table. Because I have a specialization in exploration, I have a specialization in testing, but I am an engineer, but it's even engineers who don't identify as testers, don't identify as explorers, really care a lot about testing. So we have a variety of things that means. The core one, if you've heard of Pivotal at all, who has heard of Pivotal or Pivotal Labs, by the way? Okay. So we have, our history is as an agile, extreme programming consultancy. We have since, that's Pivotal Labs. Pivotal Labs got squished together with some pieces of VMware, some pieces of EMC to make this larger thing called Pivotal, which makes Cloud Foundry and some other products, but also has this mission to help, especially large enterprises, transform the way that they develop software. And the thing that we are probably the most famous for is pairing and test-driven development. So here I've got test-driven development, basically. What that means is whenever possible, before we write code, before we make any change to our production code, we write a test first. We figure out how do we want to test it, what is it going to do, what are we going to make it do, what do we want to see after that. We write that in code, then we write the test that makes it pass, and we try to make that as small of a test as possible, and as small of a change as possible, and iterate over this, and that's the primary way that we write code. And TDD is not just it's not even maybe primarily a testing practice. It is a design practice, it's a documentation practice, it's a practice for communicating with other parts of the company, it's a practice that supports pairing, but it is a testing practice because it means that we are constantly in this little cycle of thinking not just about how we're trying to do the thing, but what we're trying to do, trying to break it into small pieces, trying to look at what we're doing, constantly inspecting and reevaluating and revising. So that's sort of the beginning, the foundation of our testing and our quality practices is that we think that engineers should pretty much constantly be checking what they're doing as they're writing code, after they're writing code. Of course, we make a pretty complicated product that has a lot of integration components. I actually have never been on a team where most of what I was doing was writing code. Probably the closest actually was on billing and accounts management. That's the team that makes the front end for our hosted version of Cloud Foundry, Pivotal Web Services. But on all the other teams that I've been on, including the team that I'm on now, primarily what we do is configuration, making changes to the manifest, the YAML manifests that control how Cloud Foundry is going to be deployed, how things are going to be deployed on Cloud Foundry. And sometimes that means that you just can't write a unit test. You're not actually making a change to the code. You're doing something like what this commit is doing here, disable auto SST false. That's basically turning on an entire other, a whole feature, right? That's, there's a bunch of other code behind that. The SST is, this is for our database stuff. Basically what this is saying is normally we make this product that's a highly available MySQL, 3 nodes. If one of them falls behind the others, if the replication doesn't keep up, they will ask for data from another node, and they will even like drop all their data and then get a backup from one of their buddies. That happens when they crashes. And this is a feature that disables that says, hey, if you fall behind, if you get turned off and you realize that your data is wildly out of the sync with the rest of the cluster, stay down. This was actually a mitigation feature for a fairly serious bug that we have that we're working on in the product. But that was a really complicated integration-y feature that touched a lot of different pieces, and we wanted to be able to turn it on or turn it off for any particular deployment of MySQL. So we have this whole piece of code, disable auto SST false. There's a lot of code behind that that's transforming things. And we couldn't really write a unit test. Like you can write a unit test that says, oh yeah, it says false, but that doesn't tell you anything. What we always try to do in those situations when we can't write a unit test is find some other way to test it. So in this case, we fired it up with disable auto SST false and deployed it, put it into the state where it was going to exhibit this behavior, checked that it was doing that, and until we had done that and seen it and looked at it, we did not check it in and commit it. We feel pretty strongly that the developers should do that kind of testing first before anybody else hits the product. I think we may even have written some integration tests around this particular feature, but that's one of the things that's really, really great about Pivotal, and it makes a place that doesn't have any testers a really nice place to be a tester, is that as a tester, I have a certain amount of status and respect for being the person saying, hang on a minute, just because we can't write a unit test around this doesn't mean that we can't test it, right? Like reminding my team, reminding the person that I'm pairing with that like, oh, hey, we actually can test this. There's a way that we could do this. It's, you know, it's ad hoc. It's not terribly automatable necessarily, but we can do it that way. And I'm not the only person who looks at things and thinks about things that way, but that's always something that gets your pair to go, oh yeah, that sounds really good. Like we should do that. People like testing. They value testing. We also do a lot of continuous integration, because that's where these suites of tests that we write end up, is usually in some kind of continuous integration system. This is a tricky picture because there's enough stuff going on here that you can't actually see the labels on any of those jobs. That's not a big deal. It gives you a general idea of what this dashboard looks like. This is one of our main dashboards. The team will be looking at this and seeing, oh, it goes red, and then you know from where it is in the pipeline what it is. This is concourse, and basically what this pipeline is it's the first couple of rows of that are, this is for the main CF release, the final integration pipeline for Cloud Foundry itself. So when the other teams that have written pieces of Cloud Foundry, you know, the runtime team or the main API team or the log aggregator team, they push, and then those components, new versions of those components get brought into CF release, the final thing, and then integration, unit tests get run, integration tests get run, and because it's a platform, we have to do things like deploy it on each of, that's the, I think the fourth column there, no, the third column there is actually we're deploying it across different stacks. So we're deploying it to AWS, we're deploying it to OpenStack, we're deploying it to vSphere, and then we're going to run a set of tests. We're going to run our standard acceptance test suite on the Cloud Foundry that's deployed on each of those environments, and that's a pretty standard workflow, which is why we have Concourse. It's why that we experimented with Jenkins, we experimented with GoCD, we ended up settling on Concourse because we needed so often to fan out, run the same set of tests across different environments, or run a number of different very expensive long-running tests that we had to parallelize. So we wanted to deploy it to multiple environments that were the same and then run different tests on them. And we talk a lot about continuous integration. We think about it a lot. We try to have some kind of automated validation happening basically every single time that we do any kind of check-in. And Concourse is a cool tool for that. The idea is to make it relatively easy to do that kind of thing. You learn one basic set of resources that you're pulling in, how to do a job and do work on them, and then push back out. And once you have that sort of general language, you can do a variety of different things with it. Once you know how to pull in from GitHub and push out to GitHub, you also know basically how to pull in from an Amazon S3 bucket and pull in, just regular files and push them back out. And it's the kind of thing that we care about a lot because we care about tools that make it easy for us to do the kinds of testing that we care about. Another thing that's cool about Concourse is that it is really explorable in itself. Concourse is a tool where all the things are made out of basic concepts, resources, jobs, pipelines, and the configuration of a Concourse pipeline is not done by hand in an interface, in a GUI. It's actually a YAML file. It's a text file, which means that when you were trying to learn, for instance, how Concourse works, how this tool of everything I know about containers, I learned from Concourse. I learned from playing around with Concourse, pushing things, trying it, having it not work, making another small change, pushing it again. So we have this tool that's really highly explorable itself because we value exploration, we value being able to explore. And this is just an example of the kind of work that we do with Concourse. This is deploying CF MySQL, the open source release of the MySQL release, to an environment. And the deployment itself has failed. The tests haven't even run. The tests usually don't fail. Usually we find problems in the deployment because, again, this is complicated and lots of different little moving pieces where the failures are usually pretty simple, but there's enough different moving pieces that one little thing being wrong with the way that one thing is configured can cause the whole thing not to work. And so here, this is an example of something that I spend a lot of my time doing, which is saying, this job, MySQL Z1, is not running because one of the processes on it didn't start running after update. And so Concourse is going to let me see, okay, that's the commit. That's me, I broke it. And then that's the environment that it's running on, and I can go, the lock name, the IP address in it, and I can go and I can log into that exact environment. If I need more information about how the job failure happened, I can go into Concourse. I can actually SSH in with the Concourse command line tool, fly SSH, and see exactly what is in the container that ran the job, maybe rerun parts of it if I need to iterate. So I'm in an environment where some of the best engineers at the company are focused on building tools to make exploration and testing easier, faster, better. And that's a nice place to be as a tester. The other thing that we do as engineers is we do exploratory testing. And again, this is going to be a little small. Some of you in the front might be able to read it. But the general idea is exploratory charters are just another kind of engineering work. at Pivotal. This is actually a relatively recent innovation in the last like 2 years. Jesse Alford was probably the first explorer to come in and start like teaching people, training people how to do this. But we find that the charter format is actually really nice for when you work in a tool like Pivotal Tracker and you're used to all your work being atomic stories that have acceptance criteria and a delivery, and that's just kind of how you work as an engineer. That's how your product manager interfaces with you. A charter fits in really nicely with that, of like a unit of exploratory work that can be done. In this case, explore flash messages on new AppSpan app with different account states to discover app messages that may not be displaying with new implementation. This is an explore story that was written by people that I've never paired with, who paired with people who I paired with, but then I'd left the team and new people had rolled on, which I was really proud of when I found this while I was going through these slides for the talk, is that people do see the value of stories that have informational outputs rather than working code. And it's something that engineers have been adopting, the product managers have been adopting, people see the value on it. We do still have, we don't do as much bug hunting and kind of general looking for problems kinds of exploration as I would like. But I think basically every team at Cloud Foundry now has the exploratory, the investigative charter as part of their toolkit when the product manager has a risk that they're concerned about or they have a question about the product. They will write a story in this format and then the engineers will execute it. And we use a format that is based on the book Explore It. Who here has read Explore It? Okay, so you're going to be familiar with, at least some of you are going to be familiar with explore target with resources to discover informational objective. Not everybody uses that format exactly. Like here you can see, explore the MySQL code base and running instance so that we can rule out SQL log ban as possible cause of universal replication failure, which tells you something about why I am on that team. We have a really interesting and tricky problem that MariaDB actually came in, and when they were finally able to see the problem that we have and what was happening, they were like, this should not be possible. This is a really big problem. Please help us, please give us more information when you have it. And they helped us add more debugging features actually into our release because of this weird thing that was happening occasionally. So here the PM though has not used the target resources informational objective format. He's used explore the target so that you can give me the information that I want, and that's a fine way to phrase things for a product manager. That's what he's interested in. So we've been also working on evolving the format so that it works for different people who may have different needs. That's one thing that I've learned since coming to Pivotal is the people who do a lot of exploratory work, I think immediately understand the value of that charter format, or at least are more likely to. If you haven't done a lot of it, you're not necessarily as familiar with the problems of how do I get started? There's all these different options. Which one do I pick? How do I know that I'm done? So that's one thing that we've been working on, is both supporting people as they start to discover those problems without front-loading a bunch of tools that are designed to solve problems that they don't yet have. Here you can see I actually rewrote this charter. I said explore binary logging with a Bosch-Lite, MySQL, and root and non-root users to get a little bit more specific about exactly what we were going to do, because there were a bunch of different options. I could have spun up an entire version of, I could have spun up MySQL running on AWS, but Bosch-Lite is a tool that lets us deploy this thing locally. So I was like, there's no reason to do it all the way up on the cloud. That'll be longer. And then specifying root and non-root users, because that was something that we were a little bit concerned about. And then I got a little bit more specific about the kinds of information that we were looking for, because I was like, we need to do a little bit of a general survey first before we really, we can't just jump right into ruling out the problem. We have to learn a little bit more. And so this is actually the kind of output that a lot of engineers now are starting to generate. Not everybody. Some people still just write some fairly minimal notes. That's something that we're working on. But this is sort of the standard Pivotal charter report format, where we have the summary and our findings, the procedure that we use so that the PM has a little bit better idea of what they did, and if it turns out not to be quite the right thing, then they can reject the story or write a new one that's more specific. And then I'll also have I I think some incidental findings there, yeah. I found some other things. I found some things out about Bosch Lite when I ran this. Actually, no, it's not Bosch Lite. It's the MySQL release itself. If you shut Bosch Lite off in a strange way and then bring it back up, MySQL can be in a very weird state, which isn't really relevant to users, but maybe that's going to impact how our development process is going to work. Maybe it's useful for the people who are maintaining Bosch Lite. And then I'll have bugs and stories. We'll have some link to the bugs. I have a emphasize here we should include DML inserts in our cluster health logging, because it turns out that that's a value that maybe if we were tracking that, we would start to see that number diverge from another number, and that would be a sign that replication has stopped across the MySQL cluster, that data is not reaching the other nodes from the node that the data is being written to in the first place. So we also do acceptance testing. I certainly spent a lot of my time at other companies as a tester doing acceptance testing, answering that question of product manager. Product manager comes by and it's like, is it ready? Can we release? Is the feature done? Does it do what I want? And I always had a problem with that question. I was always not really sure how to answer it, because I could just go, well, I think it works, but I don't know exactly what you want, man. I'm not, I can't read your mind. And one of the things that I like about the environment that I'm in now is when the product manager has those questions, they answer them themselves, which can cause some problems. You can see here we've got a couple of stories that are in so the blue ones are the stories at the bottom with the blue buttons that say finish. Those are stories that the engineers have picked up, are working on, but have not yet delivered. The ones that have an orange button are delivered, so that means they're done, but they haven't, maybe gone through CI. They're not ready to be accepted. Then the ones at the top with the accept or reject button are stories that the PM has yet to do acceptance testing on. They've yet to go in and look at the product and see whether it does what they asked for when they wrote the acceptance criteria. And this is actually one of the drawbacks to having your PMs do your acceptance testing is you need to do the acceptance testing relatively quickly so the engineers have fast feedback. And if the engineers are doing a ton of work suddenly, or if the PM is busy doing all of the other things that PMs do, that can get a little bit backed up. We call this a Christmas tree. And we will make jokes about it being Christmas. And in that case, we'll actually jump in. We'll maybe do some pair PMing, or one of the engineers will pair with the PM to help them do acceptance testing. We'll maybe slow down some other stories. We'll do some chores rather than more feature work. But this is a downside to having the PMs do all the acceptance testing themselves. But it is an advantage, because the PM knows better than anyone else what they meant. And not having to have the PMs communicate what they want to another person who will then communicate back to them whether or not it fits what they want. You've taken a whole node out of that communication chain, which can be very powerful and very useful. What do we got next? Which is really more than any particular testing practice, any more particular technical practice, the thing that makes this work, and the reason that, I say a lot of times when people are asking me about how Pivotal works, what we do, there's this deep foundation that's required to have your engineers be the primary people doing your testing. And one of it is like everything about the Pivotal process is designed to get people talking to each other and to make having the conversations that need to be had easy rather than hard. The number one thing is pairing. I think I've been mentioning that a couple of times. Who here is paired? Have you already heard of pair programming? We pair not quite 100% of the time, but close, like 80 to 90%. Enough that people who advocate pair programming come in and look at Pivotal and are like, whoa, we never said to pair all the time. But it works for us. We like doing it, and it means, this is actually, I think, another testing practice, because it means that as part of writing your code, as part of figuring out what to do next, as part of going to the next step, you always have someone else there. You always have to, at the very least, verbalize what you're going to do, so that's a test, right? Do I understand what I'm doing well enough to be able to explain it to someone else? You have a second set of eyes if you make a simple mistake, because a lot of bugs are simple mistakes, right? Probably the worst bug that I've ever been involved in, we took down, one of the worst, we took down the front end of the application of the Pivotal Web Services for about 15 minutes. We had put a comma in the wrong place. It was not anything deep or complex. It would not have been caught by like sophisticated exploratory testing. It was, we had left a stray comma when we were editing a configuration file. And pairing is one way to help to catch those little like, oh, I can't believe that I just forgot that kinds of errors. It's not perfect. Obviously, we still took down the front end for 15 minutes, although part of that was that the person who'd been doing that deployment had been working alone. And so we got to the point at the retrospective about that was like, anytime we deploy, even if it's really, really simple, we're going to put a pair on it. We're not going to let anybody fly solo on that because it's important. It also one of the really cool things about pairing is that it facilitates communication between people who aren't the pairs. I have been able to track down bugs, even like really weird ones that involved Unix kernel settings very, very quickly because there's this dense network of engineering knowledge at Pivotal. If I'm pairing with someone, and we run into something really weird or something about another component that we don't understand, maybe we don't know someone else who knows what's going on or how to solve a problem, but we definitely know someone who will know who to ask. So we can get up and go ask questions very quickly and get information very quickly. It facilitates other people interrupting us. Because if you have a question, Pivotal basically looked at this problem of, flow is important to programming and it's hard to deal with interruptions when you're programming. Instead of saying, that means programmers should be interrupted less, we said we should make it easier for programmers to be interrupted. We should make it so that when you get interrupted and you're then getting back to your work, maybe one person wasn't involved in the conversation, they're still holding context, but at worst, you've got two people who can go, okay, I kind of remember what we were doing, we're working on this and that, and then your pair goes, oh yeah, and then it was right in this spot here, and then you're kind of off and running. It makes it much easier to pick back up, which then facilitates asking questions rather than spinning your wheels for a couple of days or making a bad decision because you didn't fully understand the implications of what you were about to do on another piece of the product. We also talk a lot to our product managers. I wasn't able to find a good picture of our iteration planning meetings, but that's a really important part of the Pivotal process where we do a lot of that exploring requirement stuff, that sort of early tester, hey, have you thought about what it's going to do in this situation? Have you thought about what it's going to do in that situation? We do that once a week in a meeting where we go over the stories that the product manager wants done that week. And we have a conversation about it as an engineering team where we figure out roughly how we're going to implement it. If anybody has any thoughts on like, if we thought about that, we'll have a conversation about that. And then if we have questions later, the PM sits right with us. This is a funny picture. This is a couple years old, but the guy on the left is Shannon. He is the previous product manager for the current team I'm on, and the guy on the right is Rob Dimsdale. He is currently on my team. He was on it 2 years ago, rotated off, now he's back, which is a little bit unusual, but he's very good at this kind of thing of realizing that there's ambiguity, going to the product manager, asking the question, having the conversation, and that's something that, Rob was recently made a manager at Pivotal, which is a less fancy title than it sounds like, but that's, he was promoted to someone who mentors other pivots on a regular basis because really more than any other technical skill, we hire for empathy, communication, listening skills, the ability to ask questions, a certain amount of fearlessness in asking questions. And you have people around you, because you're pairing, you have people around you modeling that skill absolutely all the time. I spent the first, 6 months at Pivotal just following my pair around, going to people and asking questions, and that helped me learn who I could ask questions about various things. We spent a lot of time playing ping pong. We shoot for about twice a day. Not everybody has to play. There are several people. Elizabeth Hendrickson, who wrote Exploratory and is now the VP of Data at Pivotal, has a lifetime free pass, no ping pong. But when you don't play ping pong, we look for other ways to get the benefit of ping pong, which is an opportunity to get up, move around, and have some fun with your coworkers and do something that's not like work focused, because one of the problems with pairing, especially pairing all the time, pairing often you're maybe brand new to the project, you don't know anything what's going on, your pair has been working on it for 2 years, they know way more, much longer, they know way more, is there's a lot of vulnerability to that. There's a lot of, if you are constantly asking questions about things that you don't know, you're pretty much constantly putting yourself out there and going, I don't understand this. You're exposing a very vulnerable part of yourself. And having these opportunities to spend time, we eat breakfast together, we try to every day, having these opportunities to build a little bit of empathy for the people that you work with, the people that are around you, is a really important part of making that work and making it possible for people to feel safe to ask questions, to raise things like, what if this other thing that we haven't talked about at all, I mean, maybe you guys have already thought about it and that's why we're not talking about it, but it seems like maybe, and then everyone goes, oh no, wow, it just never occurred to us. You have to feel safe to be able to ask those kinds of questions, and you have to be able to ask those kinds of questions to ship high quality product without anyone whose main role is for it to be safe for them to ask those questions. We also have a fair amount of communication up and down the chain. This is a sign, it's a little hard to read because engineers don't have good handwriting. We've gone 0 days without hitting an executive with a dart. That's a Nerf dart. The first time was accidental. Every time after that was perhaps less accidental. We hit, I'm not sure if that was a director or if it was actually our vice president of Cloud Foundry, but there was a period where the mega team, the integration, well, because they have this Nerf gun that says mega on it. So I was like, well, I have to have that. I have to bring it back to the team. And we would just every so often just peg someone important with a dart. They thought it was funny. We thought it was funny. We talk to those people fairly regularly. They sit on the same floor as us. They are not super accessible. They are often talking to very important people wearing suits, and in those cases, we do not hit them with darts. But they are available. If I have a concern, I can talk to not just my product manager, but someone higher up in product management, someone in a different department that it might be important. I have had a couple of conversations with that vice president, Ansi, about concerns I had about exploration, about risk, about different aspects of the product that I was working on. And that's partially because I'm kind of loud and opinionated and I run around talking to people, but it's also partially because we've made a very deliberate decision at Pivotal to make it safe and try to communicate to people that they are safe talking to people outside of just their little sphere of what team they're on. We have a whole system of managers. You have a bi-weekly one-on-one with your manager, and then your manager has a bi-weekly one-on-one. It's almost certainly with a director. It used to be everybody had their one-on-ones with a director. Those are the people who are responsible for allocations and hiring, basically, who goes to what teams. So there's, very deliberately, we try to have clear lines of communication, both up and down, and across in the company, which makes it possible for them to make better decisions, which makes it possible for us to radiate information up to them, and to help deal with some of those kinds of bugs where, one hand kind of doesn't know what the other is doing, where one part of the company has asked for one thing and another part of the company is asking for another thing, and suddenly the only person who knows that these two groups of people haven't talked to each other is some random hands-on, lowest level of the company engineer. And it's important to have a system in place to allow those people to ask questions, drive that conversation back up and go, hey, head of product management, you really need to be talking to the platform architect team because you guys are asking me to do two totally different things here. Of course, we don't know exactly the perfect way to make software, right? We obviously don't. And this is another really, really important component of how the pivotal process works, is that we're constantly iterating on it. We spend an hour every week, every team, having a retrospective on what went well, what was mostly okay, what could have gone better. This is an important part of how we do testing too at Pivotal, because we understand that what we're doing is a little crazy. This idea of not having a separate testing organization is unusual, and we're trying to figure out how to make it work, maybe how to make parts of it work in other contexts, how to give people recommendations based on it, but also just how to improve it. Part of the reason that I have the job that I have is that we saw that we had a risk. This is from the rest of that talk that I showed you at the beginning. We are practicing writing charters. We are practicing explore TCP perf parameters with a list of TCP parameters and the HA proxy job, that's our router that we were configuring, to discover what those parameters do, how they can vary, what problems they might cause. Before Jesse and Elizabeth and I were at the company, we didn't have as much knowledge of how to do exploratory type work, and we realized that, like, oh, hey, Cloud Foundry is big and complicated, and just unit testing is not enough. We need to figure out other ways to deal with risks that, for instance, cut across teams. I was on this team, the high availability testing team, that was a one-off project with Jesse and I, because we realized that there was no, it was a concern, like, what happens when you upgrade Cloud Foundry? What components are available for how long, whether or not components become unavailable as they're being upgraded, what the configuration is that you need, how many redundancies you need of each job. That was a question that was important to the whole product, but that there was no individual team, each individual team had a little piece of that. Nobody was looking at the whole picture. So we are trying experiments like spinning up one-off teams to look for problems like that, problems with performance. We have brought in explorers, which actually was originally a much more separate role. It was originally you're an explorer, you mostly do exploration, you mostly train other explorers. Now my role is much more, I'm an engineer, I happen to have a specialty in exploration, but I actually don't spend most of my time on exploration. Ideally, I'm not doing a ton of exploration. Ideally, the other people on my team are doing more of the actual exploration, and I'm there debriefing, maybe helping write charters, doing that kind of thing, training. That's still something that we're experimenting with. At some point, we might have a separate testing group. We would prefer not to, for various reasons, some of them better than others. Some of it is pivots have this identity as engineers that test their own work. So having a testing group would take some getting used to, but part of it is just we like that you can fix a bug much faster if you find it yourself. You don't have the extra feedback, you don't have the loop. And there are downsides. If you're an engineer and you're doing exploration, you maybe don't have the deep expertise in testing that somebody who spends most of their time testing would have. But there's advantages in terms of the speed, in terms of not having the risk of having this maybe less technical, less respected class. That seems to be a problem that a lot of organizations have. We're not really sure how to have a testing group without having some threat of that. We don't want that. We want to have a software process that's effective but also, kind and humane. So we've been training people. We play Zendo sometimes at lunch. The engineers like it. They say, actually one of our directors said, wow, you guys should, it said to the whole company, like, you guys should play Zendo with Natalie, because it's a great way to get better at debugging RSpec failures, debugging unit test failures. People are test infected. They like testing, they like getting better at it, they're interested in it. They're interested in talking about ways to do it better. And that's a really nice place to be. It's a little bit, I said to Jesse when I first came to Pivotal, it's a little bit like being at a software conference all the time. And it's nice to work at a place where, even more than when I was working with other testers, at Pivotal I'm a place where people are interested in and passionate about experiential and just looking and finding things out and conducting experiments. And that's kind of a good place to be if you're one of the people who just enjoys finding stuff out. It's, I'm with my people. So that's my talk. I got my Twitter handle. If you want to get in touch with me later, ask questions. Got my GitHub if you want to see at least some of the work that I do. Not all of it is open source, but a fair amount of it is. You can see all of the terrible, terrible code that I am writing and will hopefully be rewriting in 2 years once I actually learn how to code. And I think we've got open season now.
Open season. So we have 116, 120. That's what I see right now. Give me 1 second. Oh, microphone. Excuse me.
How much are your PMs involved in the exploratory and acceptance testing, your product managers?
How are the product managers involved in acceptance testing and exploratory testing?
Yeah.
The acceptance testing, they do themselves. Basically the way that works is part of what a story should have ideally is acceptance criteria. And if the acceptance criteria we don't feel are clear enough, that's one of the big things that we will work on in an iteration planning meeting is how are we going to know that we've done what you want, PM? Let's talk about this a little bit more. They also do, some PMs actually I think do a fair amount of exploration. It varies a lot between teams. It varies a lot with the skills that they're comfortable with and their level of technical experience, but some of them are immediately interested in learning from me and learning more about writing better tests because they are often the experts on how users are going to interact with the product, what people want from the product, and so they see it as a really useful tool for them to get better at learning what the thing actually does, interacting with it in a way that feels more structured and more rigorous than just kind of playing around. And they also it's really important that PMs be able to write charters. So some of them are better than others, but that's a big thing. When I write charters, ideally I'm not writing a ton of charters. Sometimes I do, sometimes I don't, but they're often the ones who are writing charters. They're often, pretty commonly, actually, earlier today, my team on Slack, one of the PMs had a question about whether we were going to be able to use a particular new feature, and the engineers responded with, well, we think it should be fine, but if you want a more detailed answer, you should write a charter. So that's one of the main ways that they engage with exploration is by writing charters when they have a particular piece of information that they need to get from the engineering team.
Hi, I enjoyed the talk, but I was just curious for you as, I guess, an engineer with exploratory focus, do you take on what might be considered more traditional development tasks?
What was that, more traditional development tasks?
Yeah.
Yes. Most of what I do actually is writing code or configuring and deploying code. We do a lot of, even testers who don't have a focus on exploration actually do a lot of testing. But yeah, I came to Pivotal in large part because I wanted to write more code and I wanted to write more production code. I've been learning more Ruby, learning more Go. Right now I got to help write a replication canary in Go, a program that looks at all 3 nodes in our cluster, writes to one of them, checks if that commit made it to all 3 of them. It's a neat little Go binary. I was on the accounts management front end, which was basically, a Rails application, and I was doing development on a Rails application. I was adding features, adding fields, changing the underlying data model. So yeah, I do a lot of traditional development work.
43.
I'm scared this might be a little off topic, but it struck me when you were talking about how you pair so much. I was kind of wondering, do you have I know for us we have heuristics on when to pair. Do you have heuristics on when not to pair?
We do. We talk about that some. Our main heuristic on when not to pair is when it's not possible. if the team is odd. For instance, someone will not pair. There are certain kinds of work that we will tag sometimes if we're often going to be odd, as this would probably be better to not pair on. But we actually don't, we do try to pair as much as possible, and we're very rarely going to say, oh, that kind of work would be better to do ideally without pairing. I don't know that there's any kind of work that a pivot would say that about. Maybe if it was like really tedious, like configuration work where, that's come up a couple of times where people have said, oh, this isn't really pairing work. It's basically just one person going through and doing data entry, basically, and then your other pair is there. But even then, like, there's benefits to pairing in that situation of, a little bit of spell checking, but also just having two people who did that work can be useful for spreading context about it back into the rest of the organization. Although, I say there's nothing that we do that we would say, oh, I don't want to pair on that, but I often will use the time when I have to not pair to write charters, write risk lists, take a walk and think about the product, do some of that like higher level kind of thing. That's one thing that we're talking about right now. We're actually running an experiment as we speak about a flex hour, where we're going to have people have an hour, have 5 hours a week that they can spend outside of the office. We have core hours 9 to 5, but if people want to spend those extra 5 hours that normally used to be our core hours were 9 to 6. If people want to spend those extra 5 hours doing something solo or something outside of work or anything that, research, learning, that sort of thing, because this is a problem that we do see that we are leaving certain kinds of tasks on the table. There are weaknesses to pairing all the time. And we do see that we are losing out on opportunities for people to, kind of go off and come up with things on their own or think deeply about a problem maybe. But there are techniques you can learn thinking deeply about a problem. There are ways to learn how to do that in a pair, especially if you have that like social safety and you don't need to be off by yourself to have permission to come up with ideas that maybe you're going to be wrong. But yeah, that is something that we're talking about.
Any other questions? Great. Oh, 42.
So you said you came to Pivotal. Did you come to Pivotal as a developer with extra experience in test, or as a tester with some experience in development? And for what I assume is the majority of people there who are developers with not so much experience in test, do they become like developers who can evangelize for tests and have that experience that they can then go elsewhere and improve tests? How does that work?
Okay, so my background basically is I was a tester before I was not a developer. When I came to Pivotal, I could write some test code. I knew a little bit about WebDriver. I knew a little bit about scripting, but I had never, for instance, worked in somebody else's code base. I had to learn a lot about production coding at Pivotal. I got into testing by accident, actually. I don't have any kind of computer science background. I was an English major. I got dropped down at my first job, and they were like, well, you're really bad at data entry, but you're also kind of smart, so we don't want to fire you. So here's some books about testing, and a couple weeks before we deploy, maybe find some bugs. And, so my background was totally non-technical, totally like self-taught in those areas. I did learn a little bit more about programming as I went on, but I partially came to Pivotal for the chance to spend more time writing code full-time. Other engineers, yeah, we hire, our hiring process is pretty heavy on looking for people who could learn to test and who are interested in learning to test. The first thing that we do is we do a pairing exercise where they go through and they do a TDD exercise, basically. They implement, I think it's a hash or some kind of data structure, basically, out of primitives. And then, yeah, after you've paired with, for a couple of months, if I brought a pivot here to this organization, they would go, Wait, what do you mean all these people are talking about the developers who don't, like, how do they write code without testing all the time? The pivots who are involved in the community, which is another reason actually why we'd like to spend a little bit less time pairing, is that a lot of people, because you're spending all your time heads down in code, 9 to 6 pairing with somebody on something out of the backlog, we actually don't have many people who are going to conferences, writing blog posts. But when we do go and talk to other places, it's often about, especially very technical testing concepts. We talk to other engineers a lot about how to test, how to write unit tests, patterns for writing unit tests, automation, maintenance, that kind of thing. We really think most pivots do believe pretty strongly that most developers could stand to be better testers.
Any other questions? That's not actually a question. It's a random comment. All right, thank you very much for coming today, and thank you, Natalie.